자, 이제 두 번째, 이것도 역시 모바일을 넘어 웨어러블로라는 주제에 있는 두 번째 강연을 청해 듣겠는데요. 두 번째 강연자는 에런 그랜트 씨입니다. 이분의 주제는 Thalmic Labs, 네 분이 속한 회사 이름이신 것 같은데요. The Magic of Myo, Enriching your everyday life with gesture control technology. The Magic of 묘라고 했습니다. 묘, 영어에 없는 단어더라고요. 아마 이분이 나와서 설명을 해주시지 않을까 싶습니다. 여러분 큰 박수로 환영해 주시기 바랍니다.
It looks like they're just getting the slide set up. While they do that, it's a pleasure to be here. Thank you very much for having me here at Tech Plus 2013. It's my second trip to Korea, actually, and hopefully will be many more in the future. So I'm one of the three co-founders of a company called Thalmic Labs. And we're actually based in a small city in Canada called Waterloo. It's about an hour outside of Toronto, and it's a very interesting place these days because it's gaining momentum as kind of a tech hub and a hub of innovation and startups. And there's a few reasons why that is, which they're kind of not the point of my talk today, but it's a very interesting place to come from. So hopefully we get this. There we go. Okay. So just over a year ago, actually about a year and a half ago now, I graduated from university. And I faced the decision of what to do next. Does it go get a job at a big company, do my own thing, just sit around and do nothing? I know some people who have done that. But for me, it wasn't really a decision at all. I knew, and I had always known, that I wanted to build a product, build something that people actually want to use, and commercialize some sort of interesting technology that I'm really passionate about. And that's kind of where the Myo came from. So I was fortunate enough throughout my studies at the University of Waterloo to have worked and met and worked with these other two gentlemen who are the Stephen Lake and Matthew Bailey, who are the other two co-founders of Thalmic Labs. And we did a lot of projects together in university. We hung out together, and we knew each other very well, and we knew that we had a passion for bringing new technology into people's lives and actually, finding ways to use technology to enhance our existing abilities or give us new abilities. And this all started from the team. We knew each other for, like I said, 5 years. This was a photo of us actually paddling in a dragon boat race. I think that was at the World Championships in Hong Kong just last year. We had done all of these activities with each other, and because of that, it allowed us to build a very strong relationship and sense of trust with each other. And when you're starting a company and devoting all of your effort to it, this is something that is extremely important. So as I mentioned, we graduated last May, so about a year and a half ago, and we went on to found this company called Thalmic Labs. And when we started, we didn't actually have an idea yet. We knew we wanted to work together. We knew that we wanted to introduce some interesting new technology into the world, but we didn't know exactly what it was going to be. And we started thinking about some of these other new technologies that have been introduced recently, new ways of bringing information closer to us, new ways of interacting and collecting that information, whether it's wearable fitness or health trackers, whether it's things like Google Glass or other kind of heads-up display-based systems. And as we were thinking about all of these products, we realized one thing, which was there's been a fair amount of work done on kind of the the output modalities, so the way information is actually displayed and presented to you, but there was no, so for something like Google Glass, for example, there was no, at least we felt, there was no amazing way to actually interact with that technology. I mean, to use the glass example, there's kind of two ways. You can talk to yourself, but no one wants to be the crazy guy talking to himself on the subway. Or you can use a little swipe pad on the side, which is all right, but it's not that natural. We had previously explored some other wearable technologies. This was, you can see kind of at the bottom of this picture here, what this is. It was a device called EV, or Electronic Aid for the Visually Impaired, which was this belt, pretty big thing that you would wear around your waist, and it would detect obstacles and kind of map out the room in real time and provide that to you in the form of tactile feedback and a couple other mechanisms in order to enable people who are blind or visually impaired to navigate. And this was a good example of how we were using technology to either enhance abilities or just replace abilities that people had lost, in this case, sight. We also learned something pretty important from this, which was that if you want people to actually wear your wearable technology, you probably don't want to make it look like a giant diaper. So we spent, after we graduated, we spent a couple of months hacking around, trying out different things, and trying to see how we could solve this problem of, how can we build a better interface for the wearable technology of today and of the future. And we had the idea of using gesture control, but without using cameras. And there's a bunch of systems. There's Microsoft Kinect. There's a device called Leap Motion. There's a whole bunch of other gesture control systems, which are all camera-based. And just that very fact provides a big limitation, which is that you have to actually be in front of the camera. And it means, it's difficult to use it outside. It's difficult, if I want to walk around the stage and present. It's hard to always stay in front of the camera and have your hands or whatever in view. So we thought of a different way to do this, which was to actually record the electrical signals from your muscles and interpret those to figure out the different gestures and motions that you're making with your hands. And we weren't actually sure if this was possible when we started out. So we spent about a month and a half hacking together a very early proof of concept just to prove to ourselves that this technology could actually work. And when we powered it up for the first time in the summer of last year, it was a very special moment for us because it proved that we could actually build this technology. This was something that was viable. And it basically gave us the confidence to go ahead with it and dump everything into making this a commercial product. So I'd like to share with you a quick video clip of the very first time that we powered up our first prototype. It's a very ugly device, wires hanging off the arm, but it worked and allowed us to control a PowerPoint presentation, just flipping the slide to the next slide and going back to the previous slide.
There you are. So Aaron's also demonstrating here the robustness of the detection. The system right now is trained to recognize that hand to the left and the right gesture, and it's controlling a PowerPoint slideshow right now. But if you watch Aaron just move his hands, move his fingers around, you can see there's no gesture detected unless he very intentionally makes that gesture to the right, for example, and now the slide changes. So there's quite good differentiation between normal movements of the hand and those gestures we wish to detect. So you can see he's standing here and not trying to change it. As soon as he goes to the left or the right, finally gets that recognition.
So that was the very first one, and there were a lot of issues with that. Obviously, the wires hanging off the arm. The sensors we used for that were actually these medical grade sensors where you have to shave your skin, stick them on. They have some gel in there, and obviously not something that is going to work for you to wear every day. But again, it proved to us that this technology could actually work. And so we spent the next 6 months or so iterating on this design and building it into something in kind of more of the form that you can hopefully see on my arm here right now. So what you actually see on the screen is, again, another one of our, I think this was our second prototype here. Again, still pretty ugly kind of thing, integrated more into a band form now. And this was our very first wireless prototype. This is very similar to the one that I'm currently wearing. And in order to get to this point, we had to develop an entirely new type of sensor. So in that video clip I had showed earlier, you saw those round sensors with the wires hanging off of them, which I mentioned are disposable and all that. In order to develop this band, we needed to make a brand new type of sensor that would work for people with different types of skin, work when you're sweating, whether you're working out or you're just in a high pressure situation, work for different arm sizes, work regardless of whether you've just woken up and you're fresh and ready to go, or whether you're very tired, because all of these things affect the signals that we get. And so actually developing those sensors has been a huge challenge for us, and it's essentially taken us the bulk of that year and a half to come up with something that really works. So that video that you just saw was the video of a whole bunch of different applications that are possible with Myo. And this is a video we released earlier this year in February when we did our pre-launch campaign. And I'd like to show you right now a quick live demo with this helicopter here. Hopefully my piloting skills will be up to par. I'll try to keep it over here. Okay, actually, I think I'll come back to this one. The technology doesn't want to cooperate at the moment. So I've done this demo a whole bunch of times, and I knew one time this was going to happen, but Okay, so what I'd like to talk about now is a bit more of the technology itself and how this actually works. So what you see here is what the final actual production Myo units will look like. It's a bit different than the one, if you can see on my arm here, this is one of our kind of earlier engineering units. But it's the same kind of idea. So we have these pods around the band, each one of which contains one of our what we call Thalmic non-contact muscle activity sensors. And these are the sensors that, okay, that's a pretty good shot there. These are the sensors that detect the electrical activity that occurs when you actually contract your muscles in order to make, say, a fist or left or right. We also have a motion sensor in the band that can track motions like this to enable you, for example, to fly the helicopter if the Bluetooth connection would work. And then we have tactile feedback as well, which is another big problem with camera-based systems, is that when you're moving your hands around, you don't actually know whether, you don't have any tactile feedback to know whether you've accomplished your goal, whether it was clicking on something or moving something or whatever it is you're trying to do. The only feedback you have is that visual feedback from whatever screen that you're looking at. In our case, we have a vibration motor built into the band that can give you some amount of feedback as to, for example, when you've recognized a gesture or completed an action. If we can possibly get a shot of this screen here. So hopefully you guys can see this. What's actually being shown right now is the live output from the muscles in my forearm. There we go. So if I hold my hand at rest, you see the signals are fairly small, not too much going on right now. If I do something like squeeze and make a fist, you can see all of those signals getting much, much bigger. And so those are the actual raw muscle signals coming back from these 8 sensors around my forearm. And then what we do with this data is this raw data on its own is not useful, but we have machine learning algorithms which process this data and are then able to detect whether you're going left, right, making a fist, other things, kind of motions like this we can detect. We can detect if you were counting, for example, like that. So there's a whole bunch of different gestures that we can detect with that. What we've actually found, though, in testing with users is that we don't need 10 or 20 or 30 different gestures in order to make this a useful product. We only need about 5, 6, maybe 7 different gestures combined with the motion control in order to give a very rich interaction experience. So earlier this year, we produced that video that you saw earlier, and we opened up pre-orders for the Myo. It wasn't a Kickstarter campaign. It was kind of similar to that, although we haven't actually charged anybody yet. But we launched this campaign in February, and we got a lot. I don't want to say more traction than we expected, but we were certainly overjoyed at the reception and response that we got when we found out that people actually want this product and started hearing all the different things that they want to use it for. So in the 8 months since we did that launch, we've pre-sold over $6 million worth of Myos. That's over 40,000 units, and I think that's over 100 countries worldwide. And currently we're just in the manufacturing phase to actually build all of those. I think the most interesting thing that came out of this, though, is all the different applications and all the different possible uses that people want to use it for. So when we launched this campaign, it was targeted mainly towards developers, software developers, kind of hackers who we thought would want to take, kind of the Myo, which is a brand new product, doesn't have any real market for it yet, take that and develop these new applications and create these new markets. And what we actually found was that only about 50% of our pre-order customers were developers, and the rest of them were business users who want to use it for presentations, DJs who want to use it to control their lights and effects or their mixing software on stage. We've had doctors reaching out to us who want to use this technology when they're scrubbed in the operating room and they're in a clean environment, so they can't touch anything with their hands, and yet they still need to be able to interact with preoperative diagnostic imagery. We've had engineers and architects and designers reaching out to us who want to use the technology to manipulate 3D models, walk through them in real time, do actual 3D CAD and design. The list goes on. Military, toys, gaming. There's the cool thing, and the reason that we're really excited about this product is just the broadness of markets that it could potentially cover. And hearing every single day the new ideas from people that we haven't even thought of yet is definitely one of the most exciting parts. So the company, as I mentioned before, we're only a year and a half old. 3 co-founders just out of university. You might say we didn't really know what we're getting into and we didn't know what we're doing, and that's certainly true to a point that we didn't know what we were getting into, but we knew that this was a technology that we were very, very passionate about and willing to just work on all the time. I mean, most of the time, it doesn't feel like work to us. And so the company just recently turned 1. This was a picture of our team at our first birthday, which is a few months ago now. I think we've grown a bit since then to a team of about 40. And we're working to really develop and refine the user experience for Myo to take it to a point where you just slip the band on and it works seamlessly to control the helicopter, for example. Obviously, we're not quite there yet, judging by the connection issue today, but that's what we're working towards. So the question is, at least for us, and what we think about a lot, is what comes next? And so what comes next for us after the Myo, but also, what comes next in computing in general? We've seen a number of kind of paradigm shifts in the way people interact with technology, starting with, command line interfaces, or maybe before that, like punch cards and things like that, command line interfaces, graphical user interfaces, Apple introducing multi-touch with the iPhone in 2007, which kind of redefined the way that we interact with smartphones. And there's no reason that it's going to stay this way forever, especially as we move towards more of these connected devices, all the wearable technologies in general. The way that you interact with the way that you traditionally interact with, say, a smartphone doesn't always make the most sense, and there's no reason to stick with that forever. And so what we're really interested in at Thalmic Labs is these new methods of interaction and how we can actually make that experience of interacting with all of your technology, from your wearable fitness trackers to your Google Glass or other heads-up display to whatever it might be, how we can make that a seamless experience. One thing I wanted to touch on was that technology, the real purpose of technology has always been, at least I think, has always been to give us new abilities or to enhance our existing abilities. And that's where wearable technology is going. That's why we want to wear our technology in the first place, is so that we can always have it with us. We can get new abilities, do new things 24/7 that we couldn't do before. Something like monitoring your blood sugar for diabetes, that would have required a lot more work before you had an iPhone connected device that you could just have with you all the time, and do that whenever you need to. So using technology and using what I want to call smart wearable technology to do that all the time is something that we're very, very interested in. And the reason I say smart versus just wearables is because something like even clothes or sunglasses, technically those could be considered wearable technology. They do enhance your ability. Sunglasses give you the ability to see better, when the sun's in your face, allow you to maybe drive in conditions where it would have been dangerous if you didn't have them. But what things like sunglasses or some of these, I guess, more primitive wearable technologies are lacking is the middle part of this kind of graph here. So the way we see it is that any kind of technology or wearable technology has 3 parts: the input, some sort of decision-making or computation, and the output. Something like the Myo, for example, falls mainly on the input side of this. Something like Google Glass tries to cover the entire spectrum of this, but in my opinion, doesn't do a great job of any of them. And in order to build a truly natural user experience for interacting with and using this wearable technology, we need to nail all 3 of these points: the input, the decision-making, and the output. Input being things like sensors to collect different data, or sensors to determine what your intents or actions are, whether it's a camera for gesture control, something like the Myo. Decision-making being making sense of that information, whether it's trying to understand the context of your actions and the context of what you're doing and take appropriate actions as a result, or whether it's trying to analyze some data collected from a bunch of sensors and say it's some health data, trying to analyze that data and give you, maybe you should go see a doctor because your vital signs aren't looking that great right now, just as a preventative measure. And then the output, which is the way that we actually get that information back from these devices. So what our goal really is to start with the Myo, nail the input experience, and then take it from there in order to develop a system that covers the entire range from the input, very intelligent decision making, to the output. And only once we're kind of at that point and have some sort of coherent whole system there will this truly be something that is seamless and natural. So I just wanted to leave you with this quote. I'm sure many of you have heard it or seen it before, by a famous science fiction author, Arthur C. Clarke, which is that any sufficiently advanced technology is indistinguishable from magic. And in order for technology to give us new abilities and enhance our existing ones, in order to actually do that effectively and not just make our lives harder, the technology has to get to the point where it feels like magic, where for all intents and purposes, for the end user, it is magic. So I'd like to say thank you at that point. It's been a pleasure to be here. Thanks.